Excellent. Right, that means we start. Okay, so today is a fun day. I will probably say this at the beginning of every lecture, but this is one of my favorite topics today. So we're doing exploratory data analysis. Please join the Slido. I will tell you why I'm excited about EDA in a moment, but we did some EDA, exploratory data analysis, of the pre-semester survey. And I thought it'd be fun to share that with you all today. So we first start with, what is the math experience of students in this class? And in these plots, the left side of the plot, this is low and this goes to high, right? So we have our bars in the appropriate order. So what do we see from this picture? What kinds of distributions are these? We haven't taught you how to reason about these, but Data 8 did talk a bit about these. They're bimodal. So some of you think, I'm amazing at calculus. Some experience. Linear algebra, this is pretty standard. Some of you think, I'm pretty good at linear algebra. And then some, meh. And maybe some of you are down here too. Linear algebra we'll talk about in a moment, but bimodal, we have two classes here. In probability, much more of you have some basic familiarity, some limited experience. This class will use all of these concepts. And we've designed it so that if you're here, or here, or here, you should be able to follow along. You might have to work a little bit harder. If you're here, come to office hours, go to section, get help. It's possible. In fact, you can do just fine if you're here, or here, or here. Okay. So I'm guessing for most of you, you can find someone in a bar near you. So you are not alone when it comes to math. Coding experience. What we have here. This is a bimodal distribution. This is a pretty Gaussian distribution. I love it. We don't often see those in this situation. And this is giving me the finger, NumPy. All right. So what's your background? Talk about Python. Many of you have some basic familiarity with Python. Maybe coming from Data 8, some basic familiarity with Python. Some of you go, I'm good at Python. Are you really? You will learn more in this class. Do not worry. This class kind of likes people in this situation, but there aren't many people here. So if you're over here, you might have to work a little bit harder. That's the point of this class. You'll learn some stuff. By the end of this class, you will move over to this box. Okay. NumPy. Many of you think, I know a little bit of NumPy, and that makes sense because the lower div classes before this class have some exposure to NumPy. This is fine. In fact, you will probably stay here in this class. We're not going to use an extensive amount of NumPy. Most of what you do in this class will be with pandas. Okay. Maybe we'll get some people to go over here, get rid of that finger, get some more Gaussian-like shape. But yeah, this is where most people are for NumPy. SQL. Where have you seen SQL before? 61, a little bit of SQL, maybe some prior experience. SQL is a very important concept. We expect people to be kind of here. And in this class, you will get to be somewhere here, between these two. So we'll do a fair amount of SQL. You will not be the world's experts at SQL, but you'll be able to become the world's experts at SQL with a little bit more practice. Okay, so you get some basics in SQL. All right, so again, I'm guessing everyone finds himself in one of these bars. If you find yourself on the left parts of these plots, that is okay. Just come to office hours, go to discussion, get help. You can make it to the right sides of these plots. Data analysis experience. Let's dig into Data 8. Inference, making these predictions, reasoning about the world. Again, when you've taken Data 8, so you'll have some familiarity with that. In this class, we'll move you in this direction. Will you become the world expert? No, but you'll be like right here. If you have significant experience, we'll teach you some new things in this class. So do not worry wherever you are on this plot. But again, if you said, I've never done any inference before, take a look at the Data 8 curriculum. There's a good book to get you moving in this direction. Data visualization. So familiarity is good. This class, we're going to do a lot of that. You will not be the world's best data visualizer, but you will learn some really cool visualization techniques. A lot of this class will touch on how to visualize data, both to tell a story, to do research, and also to learn about the data itself. Okay. No prior experience? Who's never visualized data? Come on, you've used a spreadsheet before. Must have drawn this plot looks familiar to you. So if you have no prior experience, that's okay. You will get that experience pretty quickly. Again, if you're in these two categories here, take a look at the Data 8 curriculum. There's a great online book. You can skim it. I did in 3 hours. Just scroll right through it, and you'll get some idea of these bigger concepts. Again, we will try to move you from here to here. We'd like you to be in this box, ideally, but if you're not, we'll work with you. Okay? All right. So negative. Okay. What are the potential challenges? What potential challenges do you anticipate in Data 100, and how can we help? Well, that was 2 questions. We have 1 Wordle. This plot is always entertaining to look at. The number 1 challenge is linear time. No. So a Wordle is a data visualization. It's not necessarily a great one, but it's a fun one. We make the size of the word correspond to the number of occurrences of that word in the strings that you guys gave us. We'll talk about strings on Tuesday. Time is the biggest challenge. I think that's actually correct. Time is your biggest challenge. You have to manage your time. This class, unfortunately, takes time. Learning the material takes even more time. So if you want to be in this class, you need time. If you want to really learn the material, help yourself in your future careers, more time still. Find a way to make time. Block it out on your calendar. I'm going to work on Data 100 for this time each week. You need to dedicate time. That is a big challenge. It's a big challenge in life too. Linear is a big challenge. What is linear? Why is it a challenge? I assume linear was meant to be followed by algebra. Linear algebra has historically been a source of concern for students in this class. We do use linear algebra in this class. Do not think of it as a challenge. Think of it as an opportunity. We are not going to use crazy linear algebra. We're going to use pretty basic linear algebra. If you've worked with matrices before, you should be in pretty good shape. Go into it saying, I know enough, but I'll have to pay attention and put the time in to figure out what I don't know. What are other issues? Help. Office hours. Office hours can get busy. Go to office hours. If you can't get help from a TA, talk to other people. I'm stuck on question 1, part A. Has anyone worked on that? Yeah, we're working on it. Find others to get help. When I was an undergrad, the TAs were terrible. The only way I made it through college is I learned to work with people. And it was a good part of college. In fact, the best part of college was learning how to work with people and the network I built in doing that. So help. Help yourself. Go to office hours. Meet with other people. Coding, another area of challenge. Work through stuff. When you encounter a coding problem, don't go, oh, I need to get help. Someone, what is wrong with my code? Look at it. What is wrong with my code? The error messages, they're long. Learn how to read them. Learn how to scroll to the bottom, ignore everything except that last line that says type error. Okay, what is that? Oh, I see. I used the wrong variable. Learn how to read those messages. That's a skill we don't teach you in lecture, but probably one of the more valuable skills you'll pick up in this class. All right, so we want you to succeed. How can you get help? I give you a few ways. Work with us. We'll work with you. People are worried. You can look online. Maybe ask questions in Ed or in Slido. All right, this is the fun part. What are you excited about? Every year this changes. And every year I'm shocked to see this. Why is everyone so excited about pandas? It's awful. I don't get it. It is what everyone uses. It is a skill that you get in this class that will help you in life. So I get it. Useful. Maybe you're thinking it was the animal. But anyways, pandas, common. Every year everyone says pandas. visualization. I like this one too. You do a lot of visualization in this class. We will teach you new tools, the professional tools, the tools you would use in the workplace. You'll make cool plots. You learn how to do it, how to reason about them, how to critique other people's plots. That plot is garbage. You use colors incorrectly. You'll learn how to do that here. Excellent. SQL. Why are people so excited about SQL? It's ancient. It's an all caps language. It's like before I was born, which is way before you all were born. SQL is very useful. People use this ancient language all the time today to do analysis of the latest data on the latest technology. So good skill to have. Data. I'm excited about data too. Data is awesome. I'm guessing you meant data 100, but we'll just go with it. This class is all about data, and being excited about data, EDA is that, and what we can do with it. Modeling, we'll do a fair amount of modeling. In fact, the second half of the class we dedicated to modeling, so you'll get a chance to model away. We'll learn various kinds of models for various kinds of modeling problems. But more importantly, you'll learn a general pattern of techniques that doesn't just apply to modeling in this class, applies to all modeling. And one of those such modelings is this. LLM. Raise your hand if you go, I know what LLM is. Raise your hand like, what is LLM? Okay, that's okay. You should know. It's crazy that people know what this is. This is large language modeling. We'll have a whole lecture on this. You will, at the end of that lecture, no longer find these things as magic. You will find them to be more magic. But you will understand the basic ideas behind them. And it will blow your mind that those ideas are enough to make ChatGPT work. But we teach you the concepts that make this work in this class. So you will learn that. So a very exciting semester. I'm excited to be here. Again, I'm Joey Gonzalez. I'm one of the co-instructors in case you missed the first lecture. And it is time to talk. Oh, wait, one more poll. Okay. Let's do this first. How comfortable are you with pandas? At this point in the class, which if you are very comfortable, I'm shocked. I'm still not comfortable with pandas. But what do you think? We do these polls for attendance. This one's pretty easy. Can't give it a wrong answer. All right, can I go look at it? Let's see what happens. Their middle finger, no, okay. People are, that's how I feel about pandas still, so very good. In the middle. All right, as the class goes, you'll be more and more comfortable with pandas. You'll also realize you don't know pandas as you learn more about pandas, or that it makes no sense. It's okay. You'll come to love and not so much pandas. The animals are great, the code is. All right, has everyone done it? Have enough people? Come on, vote, vote, vote. Also vote in life, it's very important. All right, let's move. Yes, so I'm excited about this lecture because it's about data wrangling EDA. I am less excited about data wrangling, but it is a big part of the EDA. I am thrilled about EDA. EDA it's basically unboxing for data scientists. It's awesome. It is exploratory data analysis. It is probably one of the most fun parts of data science, but it's kind of a pain to teach. Because it's like, how do I teach you how to do an unboxing? Open it up. All right, so we're at this part of the cycle, right here. And maybe the most important part of being at this part of the cycle is you've got data. And your job is to understand that data. Not the world yet, the data. What data do I have? You just got a present or the thing you bought on Amazon, you unbox it. What do I have? That's where we are. Yes, so it is the unboxing of data. And as I said, it's kind of an attitude, a state of flexibility, a willingness to look for those things that we believe are not there, as well as those that we believe to be there. This is by John Tukey, very famous guy, one of the early statisticians, early data scientists, invented the bit, a lot of work in computer science and statistics. So I like this because it's fun. It is also hard to teach, so we've built a mechanism to try to teach it. So before I do that, I'm going to use this unboxing analogy. You get a new thing. I ordered a new camping stove because there was a sale on REI. So I have my new camping stove. What do you do when you get that box? How do you do an unboxing? You open the box carefully. What do I have in the box? The manual. What do I do with the manual? Toss it. Who needs the manual? Then I start looking at what's in the box. What do I have? Oh, that's weird. It's got 4 parts. Oh, shoot. I forgot to get the gas. So I'm missing things. This is exactly what we're doing in EDA. You get some data. It has a manual too. Should you throw it away? Yes. You should look at the data. You should also look at the manual. It's important. But here's the thing about data. Unlike my stove, or kind of like my stove, the manuals are often out of date, wrong, incorrect, poorly worded. So you need to look at the product, the data first. And you need to look at the manual, and you need to understand where the manual is wrong, or the manual is right. You need to understand the data. This is what we're doing in this class in EDA. All right. So like I said, it's hard to teach you how to do an unboxing. So instead, we built a set of steps to think through when you're working with data. These are the steps. So first, what's the structure? What's the shape of my data? Is it a rectangle? Is it a circle? Is it a tree? I don't know. We'll talk about different kinds of shapes. What's the granularity? What is the granularity of my data? What does each piece of data represent? Are they all the same kinds of things? What's the scope? Did I get all the data? Or some of the data? Does the data reflect the thing I was hoping to get? Temporality, special kind of scope. Where does it live in time? Time is so important, as we said in the beginning of this class. But time in data is also important. When are the data created? What does a timestamp mean in my data? And then faithfulness. Is the data good? Do I have buggy data? Is my stove broken? Am I missing records in my data, right? So if you're unboxing a product, you'd ask similar kinds of questions, at least for these two, maybe. And then these are really kind of data-specific ideas. All right, so we'll go through each one of these. We'll start with structure. This is probably where we spend most of our time. What is the shape of my data? In data science, we like rectangular data. It's because regular structures are easy to manipulate and analyze. They have rows, columns. It's easy to work with. You've used spreadsheets in your life. Easy to think about. Big part of data cleaning, my data prep process, maybe data wrangling is another word, is about transforming whatever data I have to be more rectangular. Why would data not be in a rectangle? Who makes data that's not a spreadsheet? Often data isn't rectangular, and even the data that you thought was rectangular has like a list of things inside one of these rows or these cells. That's a mess. I want everything to be the same. I want all things to be one thing in each box. So there are 2 kinds of rectangular data, tables and matrices. Probably more, but to first approximations, the 2 we're going to focus on this class. What's the difference? So tables, also known as data frames for the pandas aficionados, is a collection of named columns with different types. That's weird. You would have thought it's a collection of rows. No, it's a collection of columns. Okay, that's one way to look at it. We in the data world like to think of our data as a collection of these things, columns as features that I stick together to make a table. And each of the features, each of these rows link a collection of these columns. It's a table. So I have named columns. They can have different types, and they're manipulated using data transformation languages like map, filter, group by, join, which I love these, but there's also and pandas. And that's what you did the last week and a half, and we'll continue to do throughout the semester. There's another kind of data, the matrix. Why don't we use matrices for everything? Well, matrices typically just have numeric data, though if you know NumPy, and some of you do, you can put other things inside of those matrices, but they all have to be the same type. Every entry in the matrix is the same type. And these are manipulated using the language of linear algebra. I can say as a grad student, I was like, I don't like pandas. I tried to do everything with matrices. It was a long time ago. It was a total mess. You can make a matrix for, this column is a string, so I have a string matrix. These are all number columns, so make me a number matrix. You can make this work, but it's a pain. So we will often work with data frames in this class. In fact, most of the time will be data frames or tables. And this will allow us to work with these kind of interesting data, which has different types, different kinds of information. And the column names are remarkably important because if you spend your whole time saying, oh, column 1, column 2, 3, it's very hard to keep track of what's going on. And in the process of doing data science, you're gonna make lots of columns. And the names matter because you're gonna look at it later and go, what was I doing? What is column 3? So names, types are all very important. So we work with tables. All right, so in this lecture, I'm gonna try to work through a case study using some tuberculosis data. So kind of an EDA in itself. There was this interesting result that was already known at this point in time, that the number of reported tuberculosis cases decreased sharply in 2020. What was going on in 2020? There's an election. No. COVID. Yeah, that's right. COVID happened in 2020. And somehow it got rid of tuberculosis. Crazy. Is that what really happened? Well, something else happened that's kind of weird. From 2020 to 2021, then there was this big spike, 9.4% increase in tuberculosis. What gives? It went down, then in the middle of COVID, it spikes up again. What could be the causes? People are stuck at home. Maybe COVID or tuberculosis isn't spreading. It's an airborne disease. People wearing masks all of a sudden. Maybe it's spreading less. Also, people who have tuberculosis are like, I'm stuck at home and I'm coughing. It's probably COVID. So reporting was also down. Maybe as they got better at the pandemic, they're like, oh, I should go get this cough checked. Go to the doctor. Okay. So a lot of things are going on. There was a study to understand kind of these trends. We're going to look at some of the data in that study and try to recreate some of these calculations. So can we reproduce these results using government data? All right, so we get to start our demo. We're going to work through probably the most common form of data that you will encounter when you're playing with data in the small. You go, send me your data. Pretty standard text formats, things like comma separated values. Okay. This is a tabular format. We'll have rows or records that are delimited by new lines or carriage return new lines. This is everyone that's not in the Windows ecosystem. And then the old Windows ecosystem, you had 2 characters to say, this is the end of a line. If you're using an editor, you don't see any of this stuff, so no worries. And then we have columns that are fields with names, often delimited again by columns. All right, so let's actually play with some data. All right, so these should all be posted so everyone can try to follow along. Let me zoom in a little bit. All right. So lecture 5, part 1, tuberculosis. All of these lectures begin with some imports. I'm just importing them. You don't really need to understand what's going on in these right now. But if you wanted to learn some more Python, maybe figure out what each of these things is doing. Probably don't need most of them, but we'll start here. All right, so I've imported some stuff. I want to show you something that jumps a little bit away from lecture for a moment. Here's the data. Let's look at this data. This is the actual website. Here's the data on a web page. Cool. Data on a web page. There's probably some other data on this web page too. Yeah, some more data on this web page. Would it be neat if I could just pull this data into data science and do my pandas stuff on it? Well, you can. And it's actually easy. Pandas can read HTML. Find a website with a cool table? Thought you could visualize it differently? Try pandas read HTML. Pass in the URL of the website that you want, and you'll get a collection, a list of tables. I want the very first table, or table 0. So let's run this. And that gets the first table as a data frame. I'm already going. Okay. Now, in this lecture, I'm going to work on CSV files, but I want you to know this because you can do data science on things that are interesting to you. And one way to learn stuff in this class is to not do everything, or to do everything in this class, but in addition, do something that is exciting to you. There's probably a data set in the world that you're like, hey, I wonder what would happen if I did this. It is very easy to start playing with data. All right, so that's an external website. Someone already downloaded this data. This is what it looks like. Give you an idea. I also note that this data is kind of interesting because it has like multiple sets of column headers, like group column headers, then column headers for the specific years, US jurisdiction. Yeah, lots of stuff going on with this table. We're going to look at the CSV version of it. We're going to use pandas.read CSV. This is a pretty common function. You'll use this throughout the class. It's going to read a comma separated values file on my data or on my laptop. Before I do that, one of the things that I do in my unboxing of data is I don't go straight to pandas. I don't go straight to Python. I go straight to clicking on things. Let's click on things. I have the data here. This is a little browser on the right. My data here. And I want to look at this CDC tuberculosis table. So I want to look at the CSV version. You now have this cool file browser in your Jupyter environment. Click away. I got a little spreadsheet right here. I can look at the data as a spreadsheet. I can scroll around. Probably even edit things. No, I can't edit it here. You see, I've got these columns. I've got columns here and then another set of columns here. We kind of expected that. So you have like this years here and then this TB incidence probably applies to these groups of columns here. Fun stuff going on. This is viewing it as a spreadsheet. The computer determined that the delimiter was a comma. I could have said, you know what, I think the delimiter is a semicolon. It's not. It makes a mess of my table. So my records are separated, my fields, columns are separated by commas. There's another way to open up stuff in your Jupyter environment. You can right click. You can say open with editor. Oh, you can see the raw data. You can even edit the raw data. Don't do that. Don't edit data. Leave the data as is. If you want to make transformations, and you might, make those in your code so you can save what you did. Don't edit the data. All right, back to EDA. All right, so that's how you click around. You can also use Python to take a look at your data. So here I use the open function. So we'll teach a little bit of Python here. This opens up a file object, lets me read from the data on my computer. So opening up this file in the data folder, CDC tuberculosis CSV. I'm opening up for reading. And I'm opening up as this file object F. Right now I can loop through the fields of F. It's a little bit fancy Python syntax here, but I'm looping over F, but I've decided to enumerate it. So I'm going to get pairs of the row number and then the row from F. The row is actually just one line of F at a time. I'm going to do this 3 times because I don't want to run the entire file. I just want to look at a few lines. You can see the lines of the file. You're like, wow, what's the space between the lines? Well, when I do this print, it's saying put the row, put a new line at the end when you're done. Print it out, next line. But the row already has a new line at the end. So we have 2 new lines. I want to see what's going on in the file. Another really cool piece of Python syntax is the repr function. And this lets me get the raw representation of that string. So let's run this. So instead of printing the string with the new line characters, I'm converting those new line characters into a /n to say there's a new line. So now all those hidden characters, those tabs, spaces stay there. Tabs, new lines, and all those other things are now visible, and I can see what's going on in my file. We have weird files. This can be very useful for reading what's going on in your data. So came to my office hours. How do I know what these functions do? I look it up. I'm too lazy to do that. So how do I look up stuff quickly? Show contextual help. Now, I just put my mouse over things. It explains what's going on. Repr returns a canonical string representation of object. Cool. I don't know what that means. I can go search on the internet and get some more explanation. I can also put this on row. Let's see, or I. Yeah, so individual variables, I can see what's going on. It's a very useful tool. So when you're confused, learn how to use help. Not the office hours kind, but the computer kind. One other cool trick for those who are like, actually, I'll show you as we keep going. All right, I'm not going to go on a brief tangent because my tangents are never brief, but there's some code you can read for how to read larger files. The synopsis of this is when you have really big files, be careful because you can open up a big file in your browser and your browser's like, okay. And Python's like, okay, here's 1,000,000 lines of text and your browser crashes. And it crashes in a way you're like, oh, let's fix it. You open up the notebook again and your browser crashes. So you need a way to clear the notebook. There are tools to do that. So just be careful opening up massive things in your browser. And tangent. Oh, return to slides. Okay, very good. All right, so that is, we didn't read the CSV file, did we? It's a bummer. We did not. Okay, so let's finish it. I need to go at the end of this tangent. All right, so now I want to read the CSV file. So read CSV is a very useful function built into pandas. It's kind of one of the more powerful functions because it figures crazy stuff out. You give it a CSV file and it goes, I can often guess what you're trying to do. All right, so I'm giving it the file name. I'm going to run it. I get this data frame. It figured out it's a comma separated value file. I did say CSV, so that's a default assumption. It loaded my data in. So I have a data frame. There's this unnamed column. And that's because, remember, there's these two rows. There's this first row, which just had these like TB cases and TB incidents, and the second row seemed to have the actual column names. So there's a header. And I want to start with the actual header with the actual columns on row 1, not the row 0 of that file. All right, so let's clean it up a little bit. All right, so now I threw away the stuff that came before this. So I have 2019, 2020, 2021. And then when it was loading, it's like, wait a second, you have column name 2019 again? It appended a .1, so I could differentiate it. What does 2019.1 mean? I have no idea. So I'd go back to my file and go, okay, aha, 2019 occurs under this TB incidents thing. That's probably TB incidents 2019. And then 2019 over here is no TB cases 2019. And no TB cases 2020. How do you know what this function does? How did I know to do header? Read the documentation or Shift Tab. Hit Shift Tab and the documentation pops up. You can start guessing. Oh, there's a delimiter, names, engine. There's a CSV engine. Yeah, you can change the way it does stuff. Skip initial spaces, skip rows, skip footer, number of rows to load, verbose. Sure. What do these things do? I don't know. You scroll down and it explains each of these things. So Shift Tab, when you're confused, Shift Tab. Shift Tab. Questions? Command I goes to the context menu. And on my Mac, it's currently not working, so I've been clicking here. Command I brings up the same thing on the side. The cool thing about Command I is I can also like put my cursor here and it shows me the data too. So it reads into my Python environment. If the thing hasn't been run yet, if I hadn't run the cell and I had done this, it will show me nothing. Why? Because tbdf doesn't exist yet until you run the cell. Okay. So this is actually reading into what's in the Python environment right now. I don't know what's in the Python environment. Does anyone know? Who lists all the variables that are in your environment right now? It's a crazy name for a function. Okay. All right, so let's clean up the data. So I'm using another function built into pandas, rename. So what does rename do? I don't know. Shift tab. Okay, rename columns or index labels. Sounds good. I want to rename columns. 2019 should be TB cases 2019. 2020 should be TB cases 2020. So I built this dictionary. How did I know to do that? I don't know. Let's see. Shift tab. Columns. Mapper is a dictionary-like object or a function. Dictionary-like object, also known as a dictionary, is a mapping from the thing that it was before to the thing that I want it to be. A little dictionary. Okay. Rename columns. You will do this a lot. Ever work with Google surveys? When you get the column names, the column name is the entire question. It's really hard to work with that column when it's that long. So rename it as like question 1 or data 100 interests, data 100 fears. So you will often be renaming columns. Now we return to slides. We're going to come back to structure. Let's talk about granularity. How coarse or fine is my data? What do I mean by that? What does a row represent? Maybe looking at grades in this class. Each row could be a student and their overall grade, or each row could be a student and a particular assignment. So the granularity could be the aggregate information about a student, or it could be the information about each assignment for each student. Which one's finer? Assignment. Each assignment for each student is like really detailed, zoomed in on that student. How do we go coarser? Suppose I start with this really fine thing. You learned about a pandas function for this. I want to group my records, my rows, all the rows for one student, put them together, group by. Simple operation to change my granularity. Before we get there again, you look at your data and you should ask, what is the granularity of my data? Could it ever be more than one? Why would someone do that? It's a good question. Why would someone do that? What's going on here? This is government data. Have you ever been to the state total? They had an extra row. Why do people do that? Because humans read these tables and they're like, oh, well, I want the total. Normally they put it at the bottom, but it's hard to associate the total with the column. So maybe sometimes put the row at the top, the total column, total row. So unfortunately, in the real world, people like to mix these things. So you get different granularities. So what does record represent? It could be individual purchases, a person, a group of users. We can go from the granularity of a single assignment over here to the score for the entire class over here. And it is common for these things to be mixed. So you can get what are called roll-ups, aggregates in your table. Oops. As records. And you need to recognize those. And in the documentation, they probably won't talk about it. It's like, obviously, the totals row is a total. So they go, here are the records for the tuberculosis cases. So you need to recognize you have roll-ups and deal with them. If did our course, how do I get the records? Oh, yeah, this is a better way to frame this. If I have aggregated data, how was it aggregated? Student grades. I have your grade for homeworks. How is that computed? In this class, it's complicated, right? The average, you have some drops. There's lots of stuff going on that goes from the individual grades to that aggregate grade. Right? You need to figure that out. Hopefully, the documentation explains when things are aggregated, how they were. But again, maybe the total row they don't document. Obviously, it's the sums. In this data set, we'll find that it's actually, in fact, not always the sum. All right, this is in the way. Okay. And there are many ways in which these aggregates can be computed: sampling, averaging, some combination of the two. All right, so we're going to dig further into this. We'll work out the tuberculosis incidence. What is incidence? So I'm play with some basic probabilities, but proportions, the data analog to these probabilities. Incidence in this case is defined in cases per 100,000 persons. I like this, it could be written many ways. I actually like to think about it this way. So there's this number, which is the number of cases divided by the population. All right. What's interesting here is that if I say there were 50 cases in 2021 and then 52 cases, that's too low. If I say there are 50,000 cases in 2021 and 53,000 in 2022, is that good or bad? How do you reason about that? Did the population change? Maybe a bunch of people perished in 2020, 2021. So when reasoning about data, especially these kinds of proportions, or these kinds of population order statistics, we often think about it in terms of proportion, divided by the population. So instead, there's 0.00001, and then there's 0.00011. There's also a hard number to talk about, so we often scale these by 100,000. So how many people in 100,000 had tuberculosis? So we define incidence in this way. Understanding how these things are defined is pretty important in EDA. This is what we want to compute this thing here. So we're going to try to compute incidence. We need some things. What do we need? We have this. We got number of TB cases, right? Let's go back to our data real quickly. So we have TB cases. We should do granularity. Actually, let's finish granularity first, and we'll do the incidence. Okay. So we talked about granularity. I actually have an example of granularity in this notebook. So we'll go through it. Let's take our data. I already pointed out the total. That seems a bit weird, right? That's a different granularity record. We could actually check, how is this total computed? Is it really the total of each of these rows? What's this going to do? It's going to drop the 0th row. So now my table looks like this. Did it modify the table? Drop 0? No. Important thing to keep in mind in pandas, everything, I think, yeah, basically everything, unless you say, well, let's see, unless you say in place equals true, is going to not modify that variable, but return a new thing. Why do this? Because we'd like when tbdf is created for it to be the same throughout the notebook. So we want to do all these transformations, we should do them all at once and then have just tbdf. And anything we do to it from then on should make new data frames. All right, so we're going to drop the 0th row. If I drop the 0th row and then take the sum, what should I get? What will this do? Aggregate the entire table. I'm going to roll up all the rows, and I should get the total. Let's do it. What happened? Look ahead. What happened? Did I get the total? No. Well, maybe. I got, what is this number? I can't even parse this number. It's a big number. Being rhetorical here, so I'll go ahead and show you. When I loaded this data with read CSV, it decided that these things are objects. 2019, 2020, 2021. What does that mean to you, an object? It's the type of data, how it's stored on the machine. So in Python, objects are the things that aren't numbers like ints, floats, and booleans. Objects are things like strings, lists, dictionaries, all these more complex objects, which again includes strings. So this thing here is a complex object. Why is that a complex object? Probably a string. Why do we think that might be a string? Python goes 2, 1, 1, 1. You got a comma there. What's that comma? Punctuation. It's a string. So we need to tell it, it guessed that what it was reading here was not a number, it was a string because it saw a comma. We need to fix that. How do we do it? Oh, I gave it away. Bummer. All right, well, we'll delete it for a second. So I hit Shift Tab and I go, okay, so I got these commas. And I would start scrolling through this. And I find one. Thousands takes a string. All right, what does thousands do? Scroll down a lot. There's a quicker way to search this. There is. Go to Command I. We'll bring up that context menu on the side. Search over here. Thousands. Okay, thousands. This is hard to read, fortunately. Again, thousands. Okay, thousands is a string. It's optional. You don't have to provide it. Character acting as the thousand separator in numerical values. Comma. Comma is a separator. Interesting. So we go back over here. We say thousands equals comma. Run it again. Typo. Rename dict. Must have skipped something. Didn't run this. Rename my columns. Very good. Try it again. Down here. 2. Okay. Now I think I have things. I've renamed my columns and I've changed my numbers to actually be numbers so I can do analysis with. Should people be worried about those commas? Why would that be a problem? It's comma separated data. So how did it know what to do when it loaded in this file? It seemed to load it correctly, but I said commas separate fields, and all of a sudden I have commas inside of my fields. Do you see this? are quoted. Again, when you're doing this exploratory data analysis, you go like, I've got this data, it's comma separated, but did they put commas inside of the records? Because that's going to be a pain to load. Modern data often does this quoting. If it's good, they put the quotes there. That tells the computer that, well, okay, this thing has commas in it. It also tells the computer, this thing is probably a string because it's got commas in it, other funny characters. What if I want another quote? I need to mark that quote as well. Oops, don't edit the data. Okay, so data can be messy. When I talk about data cleaning, it's dealing with these kinds of problems in your data. Yeah. Yeah, so what if I had an old data set and they didn't do this quoting? It's really hard. I don't know. Is this a new column here, or is this, you know, a comma inside of a number? These are things you will deal with. When it's this bad, if I didn't quote, it's really hard to solve these problems. You will often do the following: drop the row. And we'll talk about that in a little bit. So what to do when you just can't fix your data. All right, got the data in. We changed the thousands. We told the Python pandas library that comma is a thousands marker. So now we have data that looks like this. The commas are gone because it's not showing the commas in the environment. If I drop the first row and I take the sum, I get 8,900. What was that up here? 8,900. So the roll up does, in fact, match what we computed. So if I compute the sums, I get, you know, the same thing. For the first three columns, right? So 7173, 7173, 7860. And I did my own calculation, 7860. And then the total number of TB instances is 2.71. 1.77 plus 7.9 plus a lot of other stuff is 2.71. How is that totaled? I don't know. Probably they computed for the population. I do in fact know that because at the end of this notebook, which we won't get to, you can actually try to work through these calculations as well. But when they mean total, they mean the aggregate for the population. So the aggregate TB incidence. Okay, so I was supposed to do this. Then I went back over here and said, all right, we want to finish this calculation. We have all this case information now. We're just missing the population. So a lot of what we do in exploratory data analysis will reveal that we're missing something. Much like unboxing my new stove for camping, I realized, oh shoot, I'm missing the gas canister, right? And you won't know that perhaps until you start taking the thing apart and looking at what you have. Here, I realize I need something else. I need the population data. All right, so we need to figure out the geographic information. Let's do that now. I think we can jump to the demo. So we get census data from the US government. I've already downloaded data into the data folder. It's in CSV form. Let's go take a look again. So we can NST estimated census 2019-01. Oh boy, what is going on here? Let's just look at this. And this is real data. We're not like cooking it to make it look bad. This is how they decided to ship it. Table with rows. So in the table, we have this like extra table with rows. Some weird character. I don't actually know what that is. It's a tab. Yeah, table with rows, header and column A. So some description, some documentation. Leading dots indicate subparts. So lots of stuff going on. When I look at it in the table form, when I just treat it as a comma separated table, it's kind of good. It's got leading dots, interesting. It's got, what are these? What's the granularity? What do you think? We got the United States, we got the Northeast, and we've got, what's the North? Yeah, Delaware. Right, so we have data at different granularities in our table. Okay. And again, this is real data. This is what the world will give you. So we looked at this data and it's got some headers going on as well. So like there's a bunch of information up here, so comments, and it looks like the real information maybe starts here on the fourth row at location number 3. So let's make this small. Actually, let's get rid of it all together. All right, so we're going to load in this data. So we get what's going on here. So there's some extra space at the beginning. So there's an unnamed column. We have Celsius, estimated census, estimated estimates base, years. So you have some of the data about the population broken down by years. We went and dealt with thousands. We pulled the data in. We have all these nan. Nan is not a number. So these are just missing values. These are probably notes at the bottom of the file that we should have ignored, but the pandas loaded it in as additional rows. So these really aren't really records in the first place. We're going to do a fair amount of data cleaning in this class. You'll do it in the homework assignments. It basically boils down to using lots of pandas functions to transform this data into a table that you'd want to work with. So I'm going to rename the unnamed column 0. It's supposed to be the geographic area. I'm going to drop the census and estimates base columns. I don't need those. I want the census is the global census. We do that every 10 years. I just want the actual year-by-year accounts. I'm going to call this magic convert dtypes function, which is going to, if I have an integer that's encoded as a floating point number, I'm going to make it an integer. And then I'm going to do drop NA. Drop not a number. So you drop all my nans. Might be dangerous, but we'll do it. Clean up our data. Come back to dropping in a moment. All right, so what happens when I run all these things back to back? I think Professor Norisi said this in the last lecture, but I've done something here just as a style to make it easy to read my code. I put parentheses so that the Python interpreter knows that this is just one long line. But instead of this being one long line that goes off the page, I've put new lines in it. I've broken it down into steps. Each of these is an object, a function call on this object. This whole thing here produces a new data frame that I then apply the drop operation to. And this whole thing produces a new data frame that I apply the convert to dtypes operation to, and so on. Much easier to read this way. Break your steps down, document them. You're like, okay, I know what's going on here, mostly. And here's my data. Done this process. I have the geographic area. I have the year. This is looking good. I have the aggregate for the United States. I have the aggregate for Northeast, Midwest, Southwest. And then I have this dot business, dot Washington, dot West Virginia, dot Wisconsin, dot Wyoming. Why doesn't Puerto Rico get a dot? Puerto Rico should have a dot. All right, Puerto Rico is not a state, so it does not get a dot. It should be. Okay, let's run this. So these dots are kind of annoying. I don't want dot Washington. I just want Washington. We're going to do more string manipulation in next week, actually. Here I'm going to take the geographic area column, and I'm using a string operator on that column. So you'll start learning about these string and date operators. If I take a series that is a series of objects, and those objects happen to be strings, then I can do .str. And there's a whole bunch of really useful functions that allow me to transform those strings. So I'm going to say I want to strip off periods at the beginning or end of those strings. That'll do. And I'm going to put that back in the geographic area column. So now, no dots. Data cleaning or data wrangling. I've been going fast. Do anyone have questions? Questions at this point? All right. So that was the 2010s, a long time ago. Now we need the 2020s. I want to look at 2019, so I need the 2010s. I want to look at 2020, 2021, so I need the 2020s. Same process again, same types of transformations. Here I put this all in one cell. This is better because when I'm done the cell, that data frame is fixed. It's the data frame I'm going to work with, nice and clean. There you go. 2020, 2021, 2022. We should update this data, download the latest version, and get 2023 as well. Return to slides. Demo complete, structure. I'm going to do something. We're a little bit behind schedule, so I'm going to jump to a break for a moment. We'll come back to some of these structure tasks. Which are a bit behind schedule. So let's do this. Let's take a 3-minute break, do a short interlude, and then we'll continue on some of the structure. No. All right. So I'm bad at time, and 5 minutes has to go a little bit faster because I'm behind on lecture. So that was a 5-minute break that was 2 minutes long. Um, Here's what we're gonna do. So I want to try to get through enough today so that we can do fun stuff with strings on Tuesday. We've been, again, playing with this data. I brought in this population data that I want to connect back to my tuberculosis numbers from the beginning of the lecture. And to do this, I want to bring in a new concept that is important when we think about data. And that is that we are often going to be operating on not one, but many, hopefully nice and rectangular, tables, data files. And in order to bring these things together, we have to use the join function, which in pandas is called merge, and also join. There's actually two. In this class, we're going to focus on merge because it is the more general version of join. It does everything that a join should do, and it's also what you learned in the last lecture. Now I'm going to talk about how you use it and what you should be looking at in your data when you're thinking about using it. And to do that, we need to think about keys. So when I look at my data, I need to figure out where some part of one piece of data references another part of another piece of data. And this is done by understanding first the concept of the primary key. So the primary key is going to be the column, and this sometimes confuses people, or set of columns, so it can be more than one column, that uniquely determines the values in the remaining columns. Actually, abstractly, a primary key is something that would be true forever if I kept filling in that table. But we're looking at, I have some data. In the data I have, what is the primary key? Let's look at some of these. I have customers.csv. It seems to have a customer ID and an address. Use your intuition. What would be the primary key? It's possible two people live at the same address. But every customer should have their own customer ID. So customer ID will determine your address. Could a customer have more than one address? Not in this world. You only get one address if that's the primary key. If customers have more than one address, this would not be a primary key in this table. Okay. Here's another one. Give you an order number. Each order gets its own number, and then you have the associated customer of the order and the date the order was placed. Very intuitive. Again, if that is the primary key, and it's a reasonable assumption this is the primary key, then I would say, well, I can't have more than one customer in an order, or more than one date for an order. So this is a concept that in database systems actually has a formal definition, but when you're working with data, you're going to be thinking, what is the primary key in this table? What is the thing that determines all the other rows? Is it the state, for example, the region? This is Washington. This is Puerto Rico. That determines the values for the rest of the columns. So it's going to be unique. Okay. And why do we need this? Because of foreign keys. Foreign keys are amazing. These are the keys that reference back to a primary key in another table. So here, customer ID is a foreign key referencing back to the primary key in the earlier table. When you have these relationships, it's time to join or in pandas merge. You need to bring these tables together to start to reason about data. I want this row, perhaps, or maybe actually want this row here. I want it attached to the side of this row. In SQL, we'll spend a lot of time working with these, and in SQL, it's actually annotated. These columns are the primary key. This column over here is a foreign key that references back to this other table. So in SQL, it's great. You don't have to figure this stuff out. It's in the schema, if the schema is well organized. In pandas and CSV land, it's up to you to figure this stuff out. All right, so demo. We're going to do a join. Get up the pace. Go. A join, aka merge in pandas. I'm going to join these tables. So I have the following three tables. But I'm using this display function to look at three things at once. Nice print, neatly displayed. So I'm looking at the last two rows of the table, the TBDF data frame. And I'm looking at the last two rows of census 2010s and census 2020s. All right, what's my keys? I think these are all primary keys. So I'm just going to connect the primary keys in each table. So the primary key in this table is Wisconsin. Let's do Wyoming. Wyoming has the following information attached to it in this table. I want to link that to the Wyoming row in this table and the Wyoming row in this table. So I have three tables, three primary keys. I can just stick them together. There should be one giant table. And you learned how to do this last lecture. So I'm going to take the tuberculosis data frame. And I'm going to merge, aka join, with the census data frame. The right side joins, merges, have a left side, the A, and the right side, the B that I'm joining together. So this is the left, then this is the right. You can see this is on the here, so make it more clear. This is on the left of the merge function, and this is on the right side of the merge function. Let's run it. Let's rewind back. All right, so a little other stuff going on here. Shift tab. Merge has these how, on, left on, all these things that will start to make sense as you play with it more, and you'll do this in the homeworks. And when we look at SQL, we'll spend a lot more time talking about some of these criterion. The one thing you do need to know is when I'm merging, the left should use the US jurisdiction column. So that is, let's go up here, left is this table. So I want the US jurisdiction column should be the thing I match on the left table with the thing I match on the right table, which is the geographic area. The right table is this one here, so geographic area. So where these, where I have Wyoming here, I will match with Wyoming here, and those two rows will be stuck beside each other. Merge. Let's see what we got. So I did the merge. The first table is a tuberculosis table. Then I joined it with the 2010 data and geographic area X. Let's comment out something for a moment. Just look clear. Let's do one merge at a time. Okay, so I did the first merge. So I have the left table is my tuberculosis table, and the right table is this geographic data table. Okay, but I put a second merge in there, which I'm merging again. Is back. And now I have geographic area X. What's that? Well, I merge with another table, the 2020 data, and have geographic area Y. When I merge two things and there's a collision on the column names, pandas adds an X or a Y or another letter if I keep merging. A number, I forget what it does. You can actually change its behavior in this case. It just adds an X and a Y, but yeah, suffixes. You'll add an X and a Y when there's a collision for the left and the right tables. All right, questions on merge? Wonderful. I'm going to clean up the data, but let's not do that now, as I want to keep going. So you saw merge. You can look at tab separated data. Tab separated data is a lot like comma separated data, except it is separated by tabs. So same new line delimiter, but instead of using a comma here, we use tab character. /T is a way of saying the tab character on your keyboard. These are also very common. We already discussed this before. We have to deal with quoted characters. If I have data that's got lots of commas in it and I don't want to do all this quoting, I could use a tab separated table and then leave the commas as is because they're now totally fine. Commas aren't delimiters, tabs are. In practice, it doesn't matter. I see these more and more. People learn to quote, so it's not such a big deal. All right, I want to talk briefly about non-rectangular data because you will encounter these in the real world. So I said, maybe it's hard to imagine data that isn't in the form of a spreadsheet or a comma-separated values table or SQL database. But you will often work with data that is semi-rectangular, things like tensors, which have like the position, latitude, position, longitude, and elevation, and then a temperature at each location. So it forms a volume, this cubic structure here. And these can be encoded in many different forms. They might be sliced as a collection of tables. They might be encoded in some zigzag, clever Z ordering on some file. And you'll use different tools to work with this kind of data. If you're interested in this, there's something called Xarray. Xarray is like pandas on steroids, which is both good and bad. So check out Xarray if you're working with really complex geographic data, this kind of rich three-dimensional structure. I did my whole PhD looking at this kinds of data, graphs, social networks, not rectangular. You can transform these into rectangles, make lists of relationships, but you'll find that there are different tools for working with this kind of data. The last kind I want to spend a few minutes on is JSON. This is very common. Who's worked with JSON before? Some of you, but not many. JSON is the JavaScript object notation. JavaScript is the modern language of the web. Websites built in HTML, but all that clicky stuff you do, all those web apps, powered by JavaScript. JavaScript stores data in JSON. Let's take a look. This is a second lecture notebook. I'm going to spend only a little bit of time on this. Did CSV, TSV, that's kind of boring. JSON. All right, There's a util function that you'll see in a lot of these homework assignments. It's a function, actually, I wrote the very first time I taught this class, to fetch and download data to your computer. This will download a JSON file, the city of Berkeley for confirmed COVID cases. It fetches and downloads it so that if I run it again, I don't keep downloading it. It's very important so that the Jupyter Hub doesn't hit the city of Berkeley's website millions of times for each student. It's also important for you. Download your data and save a copy, because guess what? Data changes. In fact, early versions of the class, I did not do that. And some of the lectures broke because I didn't have a copy of the data checked in. So make a copy of your data so you have a checkpoint in time for your analysis. All right, so I've downloaded this data. I hope it's downloaded. Downloaded, very good. August 26. Oh, it's been saved to get. Okay. There are various tools in your computing environment that you can use to look at data. I'm going to skip those for now. I want to just start to explore this JSON representation. All right, so the first thing that's kind of cool about these JSON objects is that the Jupyter environment has a way to browse through them. Looks like this. When I double click, I get something that looks like this. It's a tree. JSON stores data as a tree. What do I mean by a tree? Here's the root of the tree. It's even called the root. And then out of that, there are fields. The meta field expands into a single field, little branch, one branch. The view thing expands into all these different pieces of information. Okay? That's encoding information about the metadata of this file. Some of these meta informations, like columns, expand even more into a list of things where each thing has more information, like the field name. So I have this data which has all of this documentation built into this data. Before I get ahead of myself, what does this actually look like? Open this up. It is actually just a text data format. Looks like this. It's got these squiggly brackets. It's got fields are always quoted. Colon says the values. So this meta points to this giant block of information. Inside of it, there are lists with objects. These little squiggly brackets are more objects inside of it. Lets me represent really rich structure and data. It's kind of human readable, so you can jump in and see what's going on. And we can load this very efficiently with pandas. All right, so I'm going to jump ahead to, let's pull it in. Load the data. So when I load it into Python using the Python load tool, this lets me load a JSON object. It becomes a Python dictionary, so I can access its individual fields. I can get its keys. I can get the keys of the key. So in Python, to access a field, I use square brackets. It's a dictionary. If you don't know this, you should go maybe review some Python. So this is a dictionary. To work with dictionaries, I'm going to use the square brackets, and then the key inside the square brackets pulls the next thing. So this is like traversing inside of the meta from the root. So I click meta, and now I get what's inside of this meta object. So I can look at the meta object. It has another inside of view. So I go back over here. I go meta has view. And I open up view. I just did here. So I open up view. I get the list of keys inside of view. So I get these keys and so on. So I can recursively dive into this data. It's a tree. All right, I'm not going to go further into loading. You guys can work through playing with the tools here for importing into pandas. I want to keep going so I can get to one last concept before we go to the next thing. All right. Let's talk about types. 5 minutes. Yeah, we can do it. Let's talk about types. All right, so what is the type of data? How do I encode data in my table? So each column represents a variable. When I have my data in a nice, regular granularity form, each thing is a variable. So like TB case is a thing I'm trying to reason about, a measurement. And there are two common properties of these things. One is the data type, the storage type. How is it stored in the computer? This is encoded in .d type. Could be an integer, a floating point number, a float, a Boolean, a zero, a true false thing, an object, a string, a list, and so on. That is how it is stored. It affects the panda functions we can use. What's more critical is the type of variable it is. And this is going to affect the analysis we do on it, how we visualize it, and so on. So to answer this, you're going to have to use your knowledge of what is a TB case. You're going to explore data yourself. You'll often consult code books that might tell you what I'm about to tell you, these various types. And then again, it will affect how you visualize it and how you interpret the data. All right, so we're going to go through this. We'll review it again in the next lecture, and we'll go from there. All right, so let's get the basics out. A variable can be one of two basic types. It can be qualitative, things like often called categorical, or it can be quantitative, numbers, kinder. Let's talk about quantitative. A variable will be quantitative continuous, like a temperature or price, or it could be quantitative discrete, be the number of siblings. The distinction between discrete and continuous isn't that important. So for this class, we'll try to treat these as, quantitative. It's worth knowing these because, in some situations, a more appropriate visualization for a continuous variable may not be appropriate for a discrete variable. But it's important you be able to recognize this data is quantitative. These are often the easier ones. Now we'll talk about qualitative, where things get a little bit more messy. So qualitative has two subtypes: ordinal and nominal. Let's talk about nominal first, because that's probably the easiest of all these types. So nominal, it's in the name. Names. Nominal is referring to names. Your name would be a nominal value. Political affiliation generally could be a nominal value. Cal ID number. It's actually nominal. It's a number, but it's really just a way of referencing you. You don't take the average of Cal ID numbers. That doesn't make sense, right? So these can be actual numbers, but you're treating them as categories, as names. The one that is most tricky for students is ordinal. These are names like low, medium, and high that have an order. So preferences, levels of education. Why do I need a distinction between these two things? When I look at data and I say this nominal, the way I visualize it's actually very different than the data that the way I would treat ordinal data. And it's actually very different than the way I would treat the data on the left here. So these quantitative fields. So when you look at data, you're going to need to figure out what kind of data it is. This also makes great exam questions, by the way. I give you a table. What kind of data is it? Quantitative? Is it qualitative? If it's qualitative, is it ordinal or nominal? And that'll affect the kinds of downstream analysis you will do. And in the next lecture, we'll actually work through some examples of these kinds of types, and then wrap up EDA and start to talk about text analysis, which is a big part of finishing up EDA. Oh, I need one more slide up. Okay. Sorry, here's one more slide up in case you did not get it. I'll leave it up. Thank you.